Welcome to this course. This is a course on differential calculus, but we are going to take a slightly different approach here. What we'll do is we'll solve a lot of problems, and through the problems, we'll try to understand the concepts that are important in the subject. So this is an approach to learning the subject through problem solving, and the best way to take this course for any student is as we do the questions, you should try to work them out yourself. I'll be discussing the solutions and I'll be discussing important points of theory as and when they come up in the questions. The course is basically designed for JEE mains and advanced, and you will see questions gradually increasing in difficulty level until we reach the JEE advanced level and so on. So I hope you enjoy the course. There will be a lot of questions discussed here, and we're just going to begin now. So this is the first question. This says if y cube plus x cube plus 3xy is equal to 15, then find the value of dy by dx at 1 comma 2. So this is basically a situation where y is equal to fx is not explicitly defined. So this is like an implicit differentiation question, not explicitly defined, right? So implicit differentiation means there is a relation and you have to find dy by dx, but there is no direct y is equal to fx, right? So the method is still the same, just differentiate both sides. So if you differentiate y cube, you'll get 3y square into dy by dx. Don't make the mistake of saying that this is just 3y square because y is a function of x. So it is a chain rule actually, and it's 3y square into dy by dx plus this is 3x square plus 3 times now product rule differentiation. It is y plus x dy by dx is equal to 0 because differentiation of a constant is 0. And immediately now we can solve for dy by dx here. So 3y square plus 3x dy by dx is equal to minus 3y square minus 3y minus 3x square minus 3y, right? And 3 can cancel everywhere and you get dy by dx is equal to minus of x square plus y by y square plus x. And we have to find the value of this derivative at 1 comma 2, right? At the point 1 comma 2. So x is equal to 1 and y is equal to 2, right? So therefore dy by dx will become equal to negative of 1 plus 2 by 4 plus 1, right? So it becomes minus 3 by 5. So this question basically talks about multiple concepts. It talks about implicit differentiation, then methods of actually differentiation, differentiating a function using chain rule, product rule and stuff. So very basic question. Let's move on. So the second question is uh, let fx be equal to x minus 1, x minus 2, x minus 3, so on till x minus n, where n is a natural number. And we also have f dash of n is equal to 720. Now we have to find n here, find n. Okay. So again, f dash of n is given, right? So ultimately the idea is to differentiate this. Like somehow you have to differentiate it. And if you are able to do that, then it will be easy. But the problem is that it's a product. Like there are so many factors, right? Product rule, you know how to differentiate two factors here. If there are two factors, you will differentiate one, keep the other one, plus differentiate the other one and keep the first one, right? But if there are so many factors, what do you do? So the standard approach to differentiate it is take logs first. So ln fx will be equal to ln of x minus 1, x minus 2, so on till x minus n. And when you do log here, it will split up into multiple factors which can be added like this, right? All of these will come ln x minus n. And now you differentiate the function. So it becomes 1 by fx, f dash x, because differentiation of log is 1 by fx, and then you have to do by chain rule f dash x is equal to 1 by x minus 1 plus 1 by x minus 2, and so on till 1 by x minus n, right? And the question has told us that f dash of n is 720, right? Okay, so we have to find that f dash of n. So we can say f dash of x is equal to fx into x minus 1. So I can write fx as this product, and once I cross multiply, it will become x minus 2, x minus 3 till x minus n plus x minus 1, and except x minus 2, every other factor will be here till x minus n, plus this last term will be x minus 1, x minus 2, go on till x minus n minus 1. So n plus 1, right? This is what is coming. Now, if we put n in this, what do we get? This factor becomes 0. This factor becomes 0. Every factor which has x minus 1 will become 0, right? So all the factors will become 0 except this last one. Last one will become n minus 1, n minus 2, and so on till n minus n plus 1, 1. So this is just n minus 1 factorial. So what I'm getting is that f dash of n is equal to n minus 1 factorial. And since that is equal to 720, I know n must be equal to 7 because 6 factorial is actually 720. So n minus 1 is equal to 6 and n is equal to 7. So we have solved this one also. So the idea that I wanted you guys to know here is the fact that sometimes when there are so many products, it is better to take a log first and then try to differentiate. Don't try to do it directly. It will be super annoying. Okay. Also, guys, when you're doing this course, when you're looking at these videos, don't just look at the problem and the solution. You should pause the video and try to do it yourself. The maximum amount of knowledge that you will gain will be when you actually attempt to solve it, and maybe you get it yourself. And if you don't get it, then you look at the solution. So feel free to pause the video after the problem and try it yourself once before you look at the solution. The next question for us will be question number 3. And in this question, we'll learn about the concept of parametric differentiation. So the question says, let the parametric equation of a curve be x is equal to 1 minus t square by 1 plus t square, and y is equal to 2t by 1 plus t square. Now, if the equation of the normal to the curve at the point t is equal to 2 is y is equal to ax plus b, then basically find 3 times a plus b. So straightforward question. If you know parametric differentiation, here however, the parametric definitions of x and y are such that it suggests that you should probably put t is equal to tan theta here. Like if you put t is equal to tan theta, notice what happens. X becomes 1 minus tan square theta by 1 plus tan square theta, and that is equal to cos 2 theta, and y becomes 1 plus tan square, y becomes 2 tan theta by 1 plus tan square theta, which is sine 2 theta. However, how do I know these things? You can prove this very easily. This is a simple identity, and this is a standard identity in trigonometry. So the substitution t is equal to tan theta just converts x to tan 2 cos 2 theta and y to sine 2 theta. And therefore the equation will be simply x squared plus y squared is equal to 1, right? Because cos square plus sine square will be 1. So this is my equation of the curve. And I want to find the situation when at the point t is equal to 2. I want to find normal, right? So tan theta is equal to 2 is my point. That point I want to find the normal. Let's find out x and y there. So if tan theta is equal to 2, my perpendicular is 2 and my base is 1. So at that point sine theta will be what? It will be 2 by root 5, and cos theta will be 3 by root 5. 3 by root 5, right? No, it will be 1 by root 5 cos theta. So cos theta and sin theta are these. So cos 2 theta and sin 2 theta, that is what we have to find out. What is cos 2 theta? Cos 2 theta will be cos square theta minus sin square theta. So 1 minus 4 by 5. So minus 3 by 5. And sin 2 theta is actually equal to 2 sin theta cos theta. So 4 by 5, right? These are the values of cos 2 theta and sin 2 theta at this particular point. So why did I actually find that? I found that because I need the xy coordinates of my point P, right? Xy coordinates of point P are cos 2 theta and sin 2 theta. And since I know the parametric value, I know theta, tan theta is 2, and therefore I found P as minus 3 by 5 and 4 by 5, right? Now equation of normal at this point is super easy. At this point, we have to draw normal to this curve. This is a circle. So what we can say is simply find the slope of tangent at this point. So 2x plus 2y dy by dx is equal to 0. Therefore, dy by dx will be equal to minus x by y. And therefore, slope of the tangent becomes minus of x. So it will become 3 by 4. So slope of normal is equal to minus 1 by slope of tangent. So that becomes 4 minus 4 by 3. Therefore, equation of the line should become what? Y minus y1. So y minus 4 by 5 should be equal to minus 4 by 3, x minus minus, so x plus 3 by 5, right? Multiplying by, bringing it all on one side, you get y, you get this 4 by 5 will cancel actually, minus 4 by 5. So this term cancels and you get minus 4 by 3x. Y is equal to minus 4 by 3x. So A should be equal to minus 4 by 3 and B should be equal to 0. So A plus B is minus 4 by 3 and 3 times that is minus 4. So the answer to this question, 3 times A and B is equal to minus 4. So what was the idea here? The idea was X was written as a parametric definition of T. X was written as a parametric definition of T, Y was written as a parametric definition of T, GT, let's say. The normal method to do dy by dx here is to say dy by dt divided by dx by dt. Whenever you have x and y as functions of a third variable. But in this particular case, we didn't do that because in order to do the derivations, differentiation with respect to t and all, I would have to differentiate this y using quotient rule. And quotient rule can be annoying because it will be slightly long. And similarly, x also would also be by quotient rule. So I don't want to do that. So what I saw was that this pattern suggests the substitution x is equal to t is equal to tan theta because there is an identity that we can use, right? So therefore I used that, and once you did that substitution, x became cos 2 theta, y became sin 2 theta, and we got the curve very easily. It was simple circle. This was the curve that we got, right? Once you got the curve, equation of tangents and normals as standard stuff. The way we did it was using the point slope form and the slope of the tangent by the derivative, right? So this question is also very instructive. Now let's move on to the next one. This is question number 4. Question 4 says, if f is a differentiable function, if f is a differentiable function which on R such that f of x plus y is equal to f of x plus y comma f of x multiplied by f of y comma f of x minus y, taken in order form an AP for all xy belonging to R. And we are also given that f of 0 is not equal to 0, right? Now we are supposed to find out the value of f dash 1 plus f dash minus 1. Find f dash 1 plus f dash minus 1. This is the question. So now the question is framed very weirdly because you're trying to mix calculus and algebra here. We know what an AP is. AP is an arithmetic progression where every term differs from the preceding term by a constant difference, right? So the standard condition for an AP we can write on these functions. We can say 2 times the middle term will be equal to the sum of the first term and the last term, right? So this is the relation that we get from the AP condition. Now, if I put x is equal to y is equal to 0 in this, what I get is 2 times f of 0 whole square is equal to 2 times f of 0. Now, since f of 0 is not equal to 0, we can cancel it and we get f of 0 and 2 also gets cancelled. F of 0 is coming out to be 1. This is the first result that we get by putting x and y as both 0. Now, if I put just x as 0 in this first equation, right? Just x as 0, you'll get 2 f of 0, f of y is equal to f of y plus f of minus y. Now 2 f of 0 is 2 f of y because f of 0 is 1 is equal to f of y plus f of minus y. So therefore, you get f of minus y is equal to f of y, right? And so this is true for all y, right? Because this relation was true for all x and y. So that means, first of all, it's an even function. Also, this condition will help us solve the problem here because notice that the numbers here, arguments to the f dash x are 1 and minus 1. So here also the arguments are y and minus y, right? So if I differentiate this expression, what I will get is f dash minus y into differentiation of minus y, which is minus dy by dx, is equal to f dash y into dy by dx, right? And dy by dx can cancel and you get f dash y is equal to minus of f dash minus y. Therefore, that implies that f dash y plus f dash minus y is always equal to 0, right? F dash y plus f dash minus y is always equal to 0. So therefore, if you put any value of y here, you will always get the answer 0, right? So again, this question tells you how to handle these functional equation type situations. And in these functional equations, what you need to realize is that you have to guess and put some values. Like here we put x is 0, y is 0. And that gave us the value of f of 0. And then again, we put x is 0 and didn't put anything for y. And that gave us a relation between f of minus y and f of y. So there is no standard method to approach questions on functional equations. All you can do is to try to guess something reasonable and hope that it works out. Like it's all up to the experience of the student who's trying to solve problems here. So the more problems you do, the better you'll become at these sorts of questions. Let's move on. Let's go to question number 5. This question says that if the normal y of y is equal to fx at 0 comma 0 is given by y is equal to x, then find the value of the limit x tends to 0. You have x square by f of x square minus 20 f of 9x square plus 2 into f of 99x square, right? So this is a strange way to frame the question, but let's try it. We know the equation of normal at 0, 0, right? So slope of normal at 0, 0 is equal to 1 because the equation is y is equal to x. So slope of normal is 1, then slope of tangent at 0, 0 will be equal to -1. So what we know is f dash of 0 is equal to -1. This is one fact that we know already, right? Now, notice that this limit is in 0 by 0 form. Why is it in 0 by 0 form? You put 0, everything is that. F of 0 minus 20 f of 0, f of 0 minus 20 f of 0 plus 2 f of 0, right? And that becomes basically minus 17 f of 0. And we know that f of 0 is 0 because 0 comma 0 is a point on the curve. Point on the curve. So f of 0 is 0. So the denominator is 0 and the numerator is obviously 0 square. So it is in the 0 by 0 form. Therefore, to find the limit, we can do L'Hopital's rule. So the limit x tends to 0 is still 2x by f dash x square into 2x minus 20 into 18x. So minus 360x f dash 9x square plus 2 into 99, 198x square. 198. So it becomes, yeah, 4 into, so 396x square, 396x into f dash 99x square. Notice that this limit is still going to be 0 by 0 because every term has an x here, right? Correct. So we'll have to do the limit once more, right? If after one time of applying L'Hopital's rule, you're still getting a 0 by 0 form, what do? You have to differentiate once more. So I will have to differentiate this expression once more. So I'll just do it here. Uh, this becomes 2 by differentiation of this. So 2 times f dash. So f double dash x square into x plus 2 times f dash x square into 1, right? Minus 360 into f dash 9x square plus x f double dash 9x square multiplied by 18x plus 2 into f dash 99x square multiplied by 198x. Now this is my expression. It's a big expression, but you have to put now limit of x tends to 0 here. So this term vanishes because it has an x. This term doesn't vanish yet. This term doesn't vanish because f dash 0 we are getting. This term has an x, cancels, cancels. This term has an x, so cancels. So what we are getting is 2 by, this is 2 f dash 0 minus 360 f dash 0, right? And we have found earlier that f dash 0 is equal to -1, right? F dash 0 is coming out to be -1. So what we get here is 2 times 2 into -1 minus minus, so plus 360. This becomes 2 by 358 or equal to 1 by 179, right? So 1 by 179 should be the answer for this, correct? Uh, so what did we do here? What was the idea? The idea was the normal to the function was already given to you, right? And if the normal to the function is given, you know slope of normal and you know slope of tangent. Slope of tangent means the value of the derivative at f dash 0 is known. Once that is known, we can actually apply L'Hopital's rule 2 times and do 2 differentiations to evaluate this derivative. And that will give us the answer, right? So that was the idea here. Let's do one last question for this particular lecture. And after that, we'll continue doing a lot more questions. So this is one last question here. This is question number 6. And it says if x is equal to sec theta minus cos theta and y is equal to sec cube theta minus cos cube theta, then what is the value of dy by dx whole square at x is equal to 0? So simple parametric function and we have to differentiate it. So let's try to find out dy by dx in the normal method where you have to do dy by d theta divided by dx by d theta, right? So what is dy by d theta here? We have to differentiate this with respect to theta. So dy by d theta would be 3 sec square theta, and sec theta differentiation will be sec theta tan theta minus 3 cos square theta, and cos theta would be minus sine theta, right? So we have 3 sec 3 sec cube theta tan theta, 3 sec cube theta tan theta plus 3 cos square theta sine theta, right? So here actually if I write a by cos theta into cos theta, I will get a tan theta here also. So what I can say is dy by d theta is actually equal to tan theta common, and it is 3 sec cube theta plus 3 cos cube theta. Similarly, dx by d theta will be equal to sec theta tan theta minus minus, so plus sine theta. Again divide by cos theta and tan theta. And what we'll get is tan theta common, and it will be sec theta plus tan sec theta plus tan theta, right? I'm just checking once. Maybe I made a mistake. Plus sine theta divided by cos multiple. Oh, this is a cos theta here. And this is a tan theta, right? I multiplied and divided by cos cos. So yeah, after this is what is coming. So it is tan theta common and sec theta plus cos theta, right? So what I can write here is sec theta plus cos theta. Why am I taking common like this tan theta and all? Because ultimately you have to divide, right? So if you divide this, your tan theta will cancel. And what you'll get is dy by dx is equal to sec cube theta plus cos cube theta 3 times divided by sec theta plus cos theta. And that can be factorized and you get dy by dx is equal to 3 times sec square theta minus sec theta cos theta is 1 plus cos square theta. This is my dy by dx. Now which point do we have to evaluate it? We have to evaluate it at x is equal to 0. So x is equal to 0 means actually sec theta must be equal to cos theta there, right? Sec theta is equal to cos theta. Now this can happen only at cos theta is equal to plus or minus 1, right? If cos theta is equal to plus or minus 1, your sec square theta will be 1 and this will be 1. And you get 1 minus 1 cancels and you get 3. So you should get slope here should be equal to 3. And we have to find dy by dx whole square. So that will be equal to 9. You understand how we did it? We are basically solving it by using this parametric differentiation method and doing each of the differentiations separately and finally evaluating the final derivative, right? So I hope you are understanding what is happening here. We will continue with more problems. We'll continue from question 6 onwards, and we'll do a lot of questions in this course, which should ultimately help you completely figure out differential calculus and get you prepared for JEE mains and advanced. So stay tuned for further videos on this, and I hope you learned something from this course.